Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to read a phase diagram and answer some questions. Let's get into this. Okay, so for this video, the question is, or what we're asked to do is use the accompanying phase diagram for sulfur to answer the following questions. So here are the following questions. So how many triple points are in the diagram? What phases are in equilibrium at each of these triple points? What phase is stable at room temperature and 1.0 atmospheres of pressure? And can monoclinic sulfur solid exist in equilibrium with sulfur gas? Okay, so let's go over the phase diagram. Now, the phase diagram gives you a relationship of pressure to temperature. And so I feel like I'm a weatherman. So here we have the temperature and pressure, and here is the phases of sulfur. So we're looking at sulfur. So we have the rhombic phase in this area here. We have the monoclinic phase here. We have the liquid phase here, and we have the gas phase here. Okay. So, and what this phase diagram shows you is the places where the different phases are in equilibrium with each other at different pressures and temperatures. So as if you follow this line, you'll see that on this side of the line is the rhombic phase. On this side of the line is the gas phase. So you can see that as long as I'm on the line here with respect to the pressure and the temperature, those two phases are in equilibrium, right? So if the pressure is higher, so if I'm at this temperature here, if I have too high of a pressure, it goes into rhombic. If I have too low of a pressure, it goes into the gas phase, right? But if I'm right at the pressure that gives that puts me on the line here, that is going to be in equilibrium, right? So I'll be at equilibrium where both the rhombic and the gas phase are together at the same time. And so as long as the pressure and temperature are such that I'm on this line, I'll be in equilibrium, right? So same thing here with this line. So here, this line shows if I'm on this side, it's monoclinic phase. If I'm on this side, it's the gas phase. So if my pressure and temperature is such that I'm on the line here, then I'll be at equilibrium between those two phases. Okay. Now, what about triple points? Triple points are points at which three phases come together, and that's where the two lines, anytime the two lines meet, that's going to be a triple point. So, for example, you'll see that this line here meets with this line here at two places, right? So at this point here, you have a triple point. So we'll label this number 1. So that's one triple point. And then if you look at this line here, you'll see that this line meets with this line here. So this is another triple point. So we'll label that 2. And as I said, we meet up here. So these two lines meet again up there. So we'll call this a third triple point. So that answers the first question. How many triple points are in the diagram? That's 3. And this is where the three phases are in equilibrium together. So again, going back to the line, we saw that if you're on a line, then you've got two phases in equilibrium. So if I'm on this line here, rhombic and gas are in equilibrium. If I'm on this part of the line here, then I've got monoclinic and gas in equilibrium. If I'm over here, then the equilibrium would be between monoclinic and liquid on this line, right? So if I'm on this part of the line, the equilibrium would be between the rhombic and the monoclinic, right? So that's if I'm on a line. But if I'm at a triple point, then I've got 3 phases, right? So here, we'll start to answer this question B, what phases are in equilibrium? Well, let's look at number 1. So at this point here, what phases are in contact with that point? Well, at this point, if I go to this side here, they would be the gas. So I have the gas phase at equilibrium. If I go on this side of the point, notice that this is in contact with the point. So I have the rhombic phase. And then on this side of the point, I have this area that would be the monoclinic phase. So I have the rhombic, gas, and monoclinic phase all at equilibrium at that particular triple point. What about number 2? So again, if I'm looking at this triple point here, then I'm looking at all the phases that are in contact with that point. So if I go to this side of the point, that's the gas phase. If I go to this side of the point, that's the monoclinic. And then on this side of the point, I've got the liquid. So the monoclinic, liquid, and gas phases are all at equilibrium at that triple point. And then if I go to triple point number 3, I'm looking at this one right here. And again, I'm looking at all the phases that are in contact with that point. So here on this side of the point, I have the rhombic, right? So the rhombic phase is over on this side. So that's in contact with that point. And then on this area here, I have the monoclinic that's in contact with that point. And then on this side, I have the liquid that's in contact with that point. For that point, then it's the rhombic, monoclinic, and liquid phases that are all together at the same time in equilibrium. So that's the answer to question B. C, what phase is stable at room temperature and 1.0 atmospheres of pressure? So that brings me to this dotted line here. So this dotted line here represents 1 atmosphere of pressure right here. So that would be 1.0. And you can see that at each of these points here, you can see it's marked as 1 atmosphere, 1 atmosphere, 1 atmosphere. So that's what dotted line is. And we want to know what phase is stable at room temperature. Well, what is room temperature? Room temperature is 25 degrees Celsius. And so we want to say, okay, well, what temperature is around 25 degrees Celsius? And so you could look at the temperatures here to give you an idea, right? So we don't really have a temperature scale here or here, and this really isn't drawn to scale. So we can look at the temperatures here. So at this point here, we know it's 95.31 degrees Celsius, right? So that's definitely above room temperature. That's not room temperature. So room temperature is going to be down here somewhere. So it's way in here, and we want 1.0 atmospheres, so that's up here. So if we take our temperature over here, so this is well below the 95.3, and if we go up, right, up to here, so we're in this area here. So that's well within the rhombic phase. So under those conditions, it's the rhombic phase of sulfur that is going to be stable. The other phases are not going to be stable at that temperature and pressure. So that's the answer to C. And then finally, D, can the monoclinic solid sulfur exist in equilibrium with the gas sulfur? So what does that mean? That means that we should have a line. If those two are in equilibrium together or can be in equilibrium together, there should be a line in our phase diagram such that on one side is the monoclinic, on the other side is the gas. And do we have a line? And we do. This line right here between point 1 and point 2. So if you have a temperature and pressure that is along this line, then on this side is the monoclinic, on this side is the gas. So where the two meet on the line is where the two are in equilibrium. So along this line right here between 1 and 2 is where you will find the monoclinic solid form of sulfur in equilibrium with the gas form of sulfur. And that, ladies and gentlemen, is how you answer those questions and how you read a phase diagram. I hope this was helpful. If it was, then please by all means like the video, share the video. Also hit the like button somewhere, I think over there. And finally, do me a favor, subscribe to the channel, help me out. Hit that notification bell up there. If you do that, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.